All right, for solving systems of equations without a graph being given to you, there's about a million different ways to do it. But we're going to look at a specific situation here where both equations are in slope-intercept form. Okay, so we'll do let's do 1, 2, and 6. Okay? That should pretty much cover what you need to know here. So in number 1, both of these are in slope-intercept form, right? Y equals mx plus b, right? Y equals m, -1, x plus b. Okay, so we could graph these and see where the two lines intersect, and that would be our solution. Okay, but we're gonna use another method other than graphing, and it's going to be called substitution. Okay, so substitution goes like this. Notice that y equals this. Also, y equals this. Okay, so since both of these, 4x minus 12 and negative x plus 3, equal y, then they should equal to each other. Okay, so another way to look at it is, since this y equals 4x minus 12, I'm going to take out this other y and put in this 4x minus 12. Okay, because I know that y is the same as 4x minus 12. Essentially, I'm setting these two things equal to each other. Okay, so that's what I'm going to do. So take out that y and put in 4x minus 12. Then you have the equal sign, and then you have negative 1x plus 3. So now you just have an equation, right, that you're trying to solve. This is an equation where x is on both sides of the equal sign. Okay, so you go to either x, it doesn't matter, and do the opposite operation. Okay, so that you see only one x. Right now you see two x's, right? So I'll go to this one. It's negative x, so I'll say plus 1x plus 1x. Okay, so this x is gone here, -1 plus 1, right? So 4 plus 1 here is 5, minus 12, bring that down, equals 3. Now I just have a two-step equation. So I'm going to go to this -12 and add 12. So I have 5x equals 3 plus 12 is 15, divided by 5, divided by 5, right? So x equals 3. So now I know that x equals 3. Once I know that x equals 3, I can go back to one of these two equations here. It doesn't matter which one. And I'm just going to go ahead and plug x in for 3 and get my y. So, for example, let me go ahead and go back to this one. Okay, so you can go back to either one, and I'll show you here in a second. So this equation here is y equals 4x minus 12. I know now that x is 3. So I'm going to plug that in. Y equals 4. Instead of x, I'm going to say 4 times 3 minus 12. Okay, so 4 times 3 is 12. So I have 12 minus 12. And 12 minus 12 is 0. So y equals 0. Okay, so on this paper it says how many solutions are there, and write the solution. So there's just one solution. Right? Where do the two lines cross? They only got to cross one time. So there's just one solution. Where do they cross? They cross at the point where x is 3, y is 0. Okay, so 3, comma 0. So x is 3, y is 0. Suppose I went back to the other one. Instead of the first one, x is 3. -3 plus 3. Hey, that's also 0. Right? So y ends up equaling 0. It didn't matter which one I went back to. Okay. Let's look at number 2. And number 2, you have the same situation. Y equals this. Y equals x minus 3. Okay, so let me go ahead and plug in. Get the shadow out of the way there. So go back and plug in. Y equals this. So I'm going to take out this y and put in -3x minus 15. Okay, so I'll do that. Take out that y and I'll put in -3x minus 15. Then comes my equal sign. Then I have the x minus 3. So essentially, I'm setting these two things equal to each other. Okay, so there is my equal sign. I have x's on both sides of the equal sign. Okay, So I just want it so that I see just one, because right now I see two. So I'll go ahead, if this is negative 3x, I'm going to go ahead and plus 3x on both sides. At this step, I could have also subtracted 1x on both sides, right? Since this is a positive 1, I could have also subtracted 1x on both sides. It doesn't matter which one you do. Just get it so that there's just 1x, okay, that you see. So this x is gone now. Now I have this negative 15 equals, all right, 1 plus 3. 1 plus 3 is 4x, and I still have that minus 3. Now I just need to solve for x, plus 3, plus 3. So I have this 4x equals negative 15 plus 3 is negative 12. Divide by 4 on both sides. So x equals negative 12 divided by 4 is negative 3. Okay, so there's one part of my answer. Now I need to go back and go, the easier one. It doesn't matter which one you go back to. So I'm just going to go back to the second one just because it has less numbers. Okay, so I'm going to go back to this one. Y equals x minus 3. X now I know is negative 3. X is the same as negative. So I want to take out this x. Y equals, take out that x, put in negative 3 minus 3. Okay, and negative 3 minus 3, if I want, I can use so, right, since it's subtraction of integers here. I can do same, opposite, opposite, same, negative 3. Opposite, minus changes to a plus. Positive 3 changes to a negative 3. So y equals negative 3 plus negative 3. Y equals negative 6. Okay, so how many solutions are there? There's just one, right? Those two lines cross just one time. Where do they cross? They cross at the point where x is negative 3 and y is negative 6. Okay, and I'll do one last one with you. Number 6. Okay, so same situation here, right? Y is that. So I have this 3x plus 4 equals 6x minus 17. Right, so there's my equal sign. All right, so let's go ahead and get the x by itself, or solve for x, right? Right now I see 2. So go to either one and then do the opposite sign because they're on different sides of the equal sign. This is a positive 3x, so I'm going to subtract 3x. So this is gone. So I have 4 equals 6 minus 3 is 3x minus 17. Okay, I'm going to add 17 to both sides. So I have this 3x equals 4 plus 17 is 21. And then I'm going to divide by 3. Divide by 3. So x equals 7. 21 divided by 3. Okay, so x equals 7. Let's go back to this y equals 3x plus 4 just because those numbers are smaller than 6x minus 17. And I'll plug in the x. So y equals 3x plus 4. I know now that x is 7. So y equals 3 times 7 plus 4. 3 times 7 is 21. 21 plus 4 is 25. So y is 25. So how many solutions are there? There's just one solution. What is the solution? X is 7, y is 25. So 7, 25.